So basically, Solitaire is a game that is played by one person, and you try and create many rows of alternating colors of cards that decrease in value. So it goes like red king, black queen, and then it just keeps going down. Now, the method is basically you play 30 games of Solitaire and you write down how many cards you can get up into the top four slots and how many cards are left in your pile. This is to record how good you are at the game, because getting cards up is a good variable and getting cards out of your pile is a bad variable, meaning that it's bad to have cards in your pile left over.
Some potential forms of bias that I identified were maybe I shouldn't listen to music or something while I'm doing it, or like a podcast, because that takes brain power, and I would get not play as well. I also should play at the same table maybe, and also uh, have no time limit when I play, so that I'm not rushing to get it done.
Now the question is, how good am I at Solitaire? We're going to have two discrete quantitative variables. P is going to equal the number of cards left in the pile, and U is going to equal the number of cards that go up into those top four slots.
So this is our chart for our U variable. As we can see, it's skewed to the right, and I would probably use our median for this one because we have a lot of outliers to the right side. In terms of spread, we got the whole 52 cards for this one. So these are the stats for the spread on the U variable. They're not very good because I kind of boofed it. I was not playing very well. This is the data that it was actually supposed to be. It was a lot lower than expected. Looking at our P variable chart using CSOX, we can see that the center is going to be skewed to the right once again, so I'd probably use that median. The shape looks to be about an even spread, maybe a little bit of peak in the middle. Not a whole ton of outliers. And in terms of spread, we can see that it's going to be from about 0 to 23. These are my stats. They're different from what they should be. This is what they should be. This basically means that I did a really good job of getting cards out of the pile, but not necessarily up top. So that means there's a lot of cards left on the table. Now it's time to ask if there is a relationship between the two variables, and also what direction it's going to go in. So it's going to be positive or negative. So here's the chart. As you can see, there is kind of a relationship because there's no variables in the middle, and also it's going in the negative direction. So as you get more cards up, there are going to be less cards in your pile. We also have a lot of influential points down at the bottom right there. That's because when you get 52 cards into the up position, you're going to have 0 cards left in your pile. So we had a lot of those come up. Our correlation coefficient was negative 0.7292. So that's going to mean that we have a negative, moderately strong relationship between the two variables. So this is the residual plot. It shows that there's a little bit of a pattern. It looks like it's a little bit two-tailed. So maybe a log of y would be better for the y category. So it doesn't fit a linear model. But now here comes the big question. What is the chance of winning any given game of Solitaire, specifically for me? So the two conditions that will allow a win are that P equals 0, so there's 0 cards in the pile left over, and also that U equals 52, so that means all 52 cards are up. Now we know our two variables P and U are not independent, and this is because, let's say, the probability of U equaling 52, which would be a win, is affected by what P is. So let's say P equals 0. That is a much higher chance than if P equals anything above 0, then there is a 0% chance that U equals 52, because then there would still be cards in the pile, and that means that not all 52 cards are up. So they are dependent on each other. So now let's define the random variable. Let's let W equal the number of wins in 30 games of Solitaire. I got 6 wins in 30 games, so it will be a probability of 0.2. is what our probability distribution will look like. K is going to equal any whole number from 0 to 30. These are variance, mean, and standard deviation for this model. Now let's switch it up. Let's say that some man offered me $2 million for every win I got in solitaire over the next 30 games. Well, this is how our stats would change from that. So, yeah. En conclusión, el muchacho quiere cambiar su estilo de punk por un pompadour. También creo que es un nuevo tipo de cerveza o un nombre de un Instagramer. Pero claro que sí, mucho tiempo, ahora te quiero y adiós.